Hi, in this video, we want to take a look at fitting the parameters of a Rasch model. Okay, so a Rasch model is a model that models the probability of an event, 0 or 1, specifically for tests. So testing is going to be really the main topic here. So there's going to be 0 and 1 for the output, 0 for incorrect, 1 for correct. Now, in the Rasch model, what it does is it fits a parameter for the student, fits a parameter for the question. So the parameter for the student can be interpreted as student proficiency, and the question parameter can be interpreted as the difficulty of the question. Now, something that is very, very important when we look at Rasch models is that if I give an algebra test here and a different algebra test here, and it's completely different students, different questions, they may be very similar questions, they may be very similar students. I can't compare the results. You can only compare the results within the test. The reason for that is because of this fitting aspect to students and to individual test items. Okay, so that's something that's very important to keep in mind whenever you look at the output of a Rasch model. All right, now, why is this an important model to be familiar with? Well, let's think about standardized testing in the United States, specifically Florida, because I'm most familiar with Florida. All right, standardized testing is where school grades come from. Now, you might go in there, you might look, hey, no, that's not 100% true. There's like college, college readiness, and there's acceleration for middle school, and look at 9 out of 10 columns of the computation and the equation. You know what? 9 out of 10-ish, it's standardized test results. Like no matter how you look at it, the results are coming from standardized tests. All right, so school grades come from standardized tests, almost 100%. There's a little bit that's not standardized tests, but for the sake of argument, it's coming from standardized tests. All right, well, that impacts property values within the zone school, right? Okay. Well, that means my house, the value depends on how students do on standardized math tests. Really? I mean, it puts a lot of pressure on those kids. And also the value of my home has a huge impact on the property taxes I pay. Okay. So that means that now government funding, the funds that a government has are dependent on third graders taking standardized tests. Well, how is that standardized test being evaluated? Well, in the state of Florida, it's a Rasch model, or like it's related to a Rasch model. It's more complicated because you can have multiple points within one question, but a good way to think about it and to view what's going on is to say it's a Rasch model. And also, funding from grants and from the government, a lot of times what organizations will do will say, hey, send us standardized test data so we can see what's going on. And they approve them. Let's say they approve the money, they send it out. And then they go, hey, send us standardized test results so that we can go and take a look and verify that you did not waste our money. Okay, that's important. Also, if a school does poorly on school grades, that school can get shut down or restructured. Teachers can get removed from their position. Principals can get fired. Some awful things for the employees of the school. They're coming from standardized tests. All right. Well, there's also teacher salaries and bonuses. So there's plenty of school districts that will pay more if you get good test results, and they'll give better bonuses if you get good test results. All right. I know several counties that it's basically the result of your standardized tests. It determines the bonus you get for the year as a teacher. All right. And then also, let's say that a school is failing. Something that can be done is that the state government will say, hey, in this school that got a D or an F on school grades, you cannot have any teachers that have weak test results from their kids. All right, so then those teachers have to get bumped out. Now the school district has to go and recruit someone to take this position. All right, now I'm not saying that all of this is not warranted if a school is failing or whatnot, but these are the impacts coming from the Rasch model. So whether you approve or disapprove of the choices that that have come out of education from the top down, if you disagree or agree, it doesn't really matter for our purpose, because, well, if this is something that we have to deal with, this is something that is a fact of our reality. And so if this is the case, we should at least know, how is the darn test being scored? Like, how are they deciding if a kid is a level 1, level 2, level 3, level 4, level 5? Like, how? Because if the kid is a 1 or a 2 and they're in 3rd grade, they could get retained. Unless they get good cause on that in the state of Florida. So that's, I mean, like mandatory retention of kids, or kids not graduating from high school based off of their algebra test. This is a big whoop-de-doo. So we really need to understand how this is scored. Okay, so the thesis, or so all I've talked about so far is just trying to motivate you to be like, yes, I need to know this. I need to understand this. Okay, so the thesis of this entire video is just this one statement. A Rasch model is a modified logistic regression model. That's it. Boom. If you get nothing else out of this video, this one highlighted sentence is what I want you to walk away with. A Rasch model is a modified logistic regression. Okay, so now I'm going to run an example, and I'm going to try and convince you that this is a correct statement. Okay, so what we're going to do, we're going to generate some fake data. Now, why am I going to use fake data? So first and foremost, I don't have to worry about FERPA of releasing student results because it's fake data. Second, I can control the output so that it's a little bit easier for us as an audience to understand what's going on. What I'm going to do, I'm going to set up so that students are going to be going from 1 to 20. So there's student 1, student 2, student 3, down to student 20. Student 1 is the least proficient overall. Student 20 is the most proficient, and so on in between. And we're going to have questions 1 through 10. And question 1 is the hardest. Question 10 is the easiest, and in between appropriately. All right, so now this step is just to make it so that we don't get blasted in the face by numbers as we look at this. All right, so here I'm going to generate my data set. And basically, I'm setting up a data frame that has a bunch of empty values, and we're going to go in and randomly put values in there. We're going to randomly generate some numbers. So I'm going to go ahead and set seed so that if I rerun the code, I'll get the same output. Now, what I'm doing here is, you'll notice I have J plus K. So students are the J's, K's are the questions, and we're setting it up so that the probability of getting a correct response, a 1 on the data set, is greater for students with greater numbers, and it's greater for questions with greater numbers. All right, so we expect to see, student 20, question 10 to be a 1, student 1, question 1 to be a 0, and there'll be like an increase in, appropriately overall. Now, something about Rasch models, Rasch model computation do not like constant values on a row, so they or a column. They really do not like to see all zeros in a row or column. They don't like to see all ones in a row or column. Okay, so how is this interpreted? If I have a student who gets a perfect score on a state test, right, they deserve a very strong value. What you do for their parameter, you just give them one that's very, very large relative to all the other students. If they get all questions wrong, then they get a large magnitude negative value, or a very minimal value compared to everybody else. They get so all zeros, they get the most minimum value of all students, and all ones, they get the maximum value. Now, in the state of Florida, if you look at the output for the EOCs or the FSAs, the schools receive a spreadsheet, and there's a column called theta. Theta is the student parameter. And if you look at it, you'll see that the values go from -3 to 3. And the students who get all questions wrong will get a -3. Students who get all questions right will get +3. And so now it's going from -3 to 3. Doesn't that sound like standard normal? Like kind of like almost everything is between -3 and 3 for standard normal. So, they are rescaling what's going on, and that's okay because because remember, we're always comparing students within the same test. Has to be the same test for us to be able to compare students. And also, if let's say I take the same test and I've got two students, I break it up and I run model on each of these separately, I'll get separate values. If I want to be able to compare students, they have to take the exact same test, and the model has to be computed with them in one data set. Otherwise, it doesn't make sense to do a comparison. Now, if you see a -3, you see a +3 for like the state test, it's a very extreme value and you can interpret that. But like, you don't know, a kid over here got a 1.1, this kid who got 1.2, you don't necessarily know that if they took different tests, that the 1.2 theta is actually a more proficient student than the 1.1, in addition to the aspects of standard error. It's just not comparable. So keep that in mind if you end up in a position to evaluate the output of a Rasch model. We cannot compare different tests in a coherent manner. Now, on this step right here with the data, I'm sorting the rows by the number of correct responses, or the average score. And this is just to help make sure that I have students ordered in the manner that I want them. And then I'm also sorting the columns in the manner that I described earlier. And this just makes sure that in a few moments, when we're looking at the output, it's easier for us to interpret what's going on. Real life the data would not be this nice. And then I put row names and column names, and see, we could see this as a data set. So we can look here and we can see that student 1, we can see that they got questions 1 through 7 all wrong. Student 1 got question 8 right, and then student 1 got questions 9 and 10 wrong. All right, so a rather poor performance. Student 20 did much better. We can see that got the first 6 questions right, got the 7th wrong, and then got the last 3 right. So student 20 only missed 1 question. All right, student 20 did pretty well. And then the students kind of like go down a gradient if we look at them. All right, so now what we want to do is we want to think about passing that data to a logistic regression. We're going to use the generalized linear model function. All right, so how this is going to work is that we want to have a parameter for the student and for the question, and those are the 2 things going in. This format does not work. What I need to have a student column, a question column, and then a 0-1 column for the score, whether they got right or wrong. This format will not work for this. This format, the level of observation is the student. For the logistic regression computation, I need to have the level of observation be the right or wrong for the individual student question combination. And so this we have here is what's called wide format. I need to convert this to long format. Okay, so I'm going to use the tidyr package, and we use gather, and I'm going to have a column for the students, a column for the question, and then the score. So we can see that student 6 on question 1 got the question wrong. Okay, now if I look at this format, I can pass this to the GLM function right now as is, which is good. Now, but this really doesn't illuminate how this is being scored. So I want to take it one step further. Okay, what happens when I pass this type of data to regression or logistic regression or generalized linear model inside R? What it does automatically, without telling me, without asking permission, it just does it like this. It converts all the student column into a bunch of dummy columns. So there are a column of 0s and 1s indicating which student is for row 1, and then it does the same for the questions to indicate which question it is for row 1, and so on. So what we're going to do, we're going to manually create that dummy variable matrix. So I'm telling the fast dummies package to take student in question and split it up into dummy columns. So remember, whenever I do regression, whenever I do generalized linear models, it never, ever, ever works with categorical data. It always works with numeric values. These are not numeric. These formats cannot be passed to the function as is. So R will automatically do a conversion for us. Here, we're going to manually do the conversion just so that we can see how things are actually computed. So here, if I take a look at the output, what the function does, it takes the entry here, and when it makes the new column, it puts this column name along with the entry and then appends them together. It takes this column and this entry and appends them together, and it does this over and over and over to make new columns. So if I didn't have this entry, this code here, this would be student for column name, student 1 for entry. This would be student 2, so student for the column name, student 2 for the entry, student 3, student for the column name, student 3 for the entry, and then it will do the same for the questions if I keep on going down. So this was question 3, question for the column that came from up in the long format, and then question 3 for the entry. All right, so what's going on here is you'll notice that on each row, only one of the student entries is non-zero. And on the question columns, only one entry is non-zero also. So if I look here, I can see those are all 0, except for this entry. That's a 1, then these are all 0. Whole bunch of zeros, then a whole bunch of zeros. All right, so this indicates that the first row, the student was student 1. Here, the second row is student 2, third row is student 3, and so on, right? Now, for the question, we can see that question 1 is the question that is being scored every single time. And we look in this column and we can see now at the top of the column, it's all zeros, means that the students got all of these questions wrong. Well, that's because of how I sorted the data. But if I go to the bottom of the data set, I would see a bunch of 1s because students performed much better down at the bottom or on the later numbered questions. All right, so now let's fit a model using logistic regression. All right, so what I'm going to do, I'm going to take the long format. So here's the long format of the data. I've got student, question, and then score. I'm going, and so there's that data set. I'm going to say that score as a binary variable depends on student plus question, and I do not have an intercept. That's important. We don't have an intercept. Now, if I want to, I could include an intercept, but for I'm trying to make this as similar to a Rasch model as possible, so I'm not going to. Binomial family says, hey, this is a logistic regression problem. If I leave this blank, it's going to assume that I'm doing multiple linear regression. Now, what's going to happen is under the hood, this will, like R will automatically convert this to those dummy columns for the fitting. And now we get the coefficients, and the coefficients will be where we get our student parameters and our question parameters. Now, what I want to do, I want to fit the Rasch model. Now, with the Rasch model, I'm going to use the ERM package, and I'm going to use RM for Rasch model. And I only pass the scores of the data. So the column that says students, I need to get rid of because it's not a question at all. Remember, so that here I've got it in wide format. Each row corresponds to student, each column corresponds to question. With the GLM model, every row corresponds to a result of individual student question combination. Here, the Rasch model, we're looking at the observation level as a student. All right, so now what I want to do, I want to extract the parameters I got for the generalized linear model and the Rasch model, and want to compare them. Now, something I do, this is just extracting, I go ahead and I scale it. And the reason why I scale that is because of how it's used, how it's implemented anyway. You know, like I said, with the state of Florida, all the values are from -3 to 3 because of standardization. So I'm going to go ahead and rescale the output of the coefficients that we get. Notice I use coefficient for both models to extract. And we can see that here are the difficulties of each question. Now, this is relative to each other, relative to other questions. So question 1 is like the baseline is where everything is being referenced off of. You'll notice that it's omitted from the calculation. And now what R does, R uses other mathematics and subject matter and knowledge of the situation to go back and assign that value. But with a generalized linear model, it doesn't do that automatically for us. If we were going to be doing this in real life, I would have to go in and manually do that computation. And so we can see that either way, I get the same value. Now, they are fitted differently. So if I was to have more digits displayed, there would be a difference, but it's not going to be a very big difference. Now let's look at the student parameters, and I go through the same thing and I extract the values. And we can see that we're getting virtually the same. There is a difference because there is something of a difference on how things are being fitted. The fitting algorithms are different. I know that the Rasch model is using maximum likelihood. I couldn't see how it's being fitted for the logistic regression, but it's close enough that I really don't care about the difference. And so the difference here is arising from the fact that it's different algorithms for fitting the models and different implementations. Also, if I had more data, more students, more questions, we would see more of a difference between these values, but it wouldn't be very large. But it would be more consistent of a difference, but it would be still relatively minor. Well, that's all I've got for you. Take care and goodbye.